All right. So today we're going to be talking about driving value at global enterprise scale using Snowflake, Kafka, and Feast. My name's Ben. This is Nisha. I'm the director of global data platform engineering at a company called ResMed. We make all the machines that help people breathe, so CPAPs for sleep apnea, POCs, ventilators, but also we have subsidiaries in the out-of-hospital EHR space, as well as SaaS providers for the pharmacies that actually sell medical devices.
Hi, I'm Nisha. I'm an engineering manager at Global Data Platform at ResMed. We're going to be using this term around a lot during our presentation, which is GDP and stands for Global Data Platform. We are truly a global organization with a full stack data engineering teams. We bring data from hundreds and thousands of system of records for ResMed and its subsidiaries into our data platform. We build and manage a centralized data platform that drives company-wide data-driven processes.
So a brief look at what we're going to be covering today. First, we're going to talk about bringing data together. So inbound integrations at ResMed cover hundreds of distinct systems of record, or SORs, but far fewer distinct types of systems of record. And so to deliver at scale, adding a new source system to Snowflake has to be as simple as leveraging existing platform capabilities and just modifying a configuration.
Next, we'll take a look at reducing time to insight, how we efficiently derive valuable insights and actionable information from data by leveraging advanced analytical tools, streamlined workflows, and automated processes for making the process quick and easy.
So then we're going to dive into building trust at scale. And trust really is the currency of any data platform. We're going to look at some of our observability and that implementation, our quality framework, and the robust data governance processes that we have in place.
We'll also take a look at how we implement practices and frameworks to ensure that data is accurate, consistent, and governed by appropriate policies and controls. Next, we'll dive into creating a data platform for machine learning. We'll explore the acceleration of machine learning experiences and transformation of insights as we delve into the power of Feast and Snowflake.
And then we're going to wrap up by looking at how we're driving value for customers, both internally and externally, using a variety of outbound integration patterns. So I mentioned a moment ago that we're dealing with hundreds of source systems. And the way that we integrate nearly all of them is with Confluent Kafka. So either using a push model or a pull model, we'll get into that in just a moment. Depending on the type of source system. We've been able to move really quickly here due to a strong bias for abstraction and automation. So when a product team spins up a storage layer like RDS or Dynamo, we can take a pattern off the shelf, add a configuration, and be streaming data into Snowflake in a matter of days. That includes self-healing data reconciliation, end-to-end observability, handling of normal course of business versus data retention-related deletes, schema evolution, and meeting all of our regulatory compliance obligations. What you're seeing on the screen right now, this diagram, this is our pull model or our change data capture model. So if you can imagine hundreds of millions of CPAPs out there in the world dialing in every day and loading a night's worth of therapy data. First, that's going to go to a message platform, which is something we're also involved with, but it's eventually going to land in a system of record. And once it's in a system of record, and think RDS or Mongo in this case, we're plugging in using a source connector with Confluent Kafka, and then we're streaming that data into Snowflake. It comes in as JSON. We effect merge, but using streams on top of Snowflake tables. And then we use row-level policies to affect dynamic views. And then that little box at the bottom right there, that's our consumption layer. It's actually a separate account, and we expose secure views to that account for downstream use cases. And then this is our self-service publication model, or our push model. This is something that we're dog-fooding internally with things like DynamoDB streams for that integration pattern. But it's also something that allows any group at ResMed to register a schema, publish data, and have it appear in Snowflake. This is really just a REST proxy in front of Confluent Kafka. Everything you're seeing on the right side is really the same as what you saw in the last slide. So bringing data together is really only the beginning.
We'll see how we reduce time to insight by our unified orchestration. It provisions per engineer development environment and transform local development workflows into robust and seamless experiences. We have introduced end-to-end lineage construct to trace the journey of our data from source to consumption. We are currently implementing a standardized data quality framework for our entire data platform predicated on tools like dbt and soda. We'll discuss quality further in a moment. The key takeaway here is that it allows all our engineers to verify the integrity of their code and configuration at every step, ensuring everything runs smoothly without any interruptions. We'll take a look at one of our orchestration observability. Across the board, we are using Datadog for observability. Here is a sample example of one of our Airflow managed instance. The numbers that you see here are for a single day from one single instance. You can see the number of DAGs that are being executed, the number of tasks. It gives us the error and success ratios. Observability is a key and a lifeblood of our operation model. It integrates with PagerDuty and Slack and enables the follow the sun support for our operation capabilities. Next, let's take a look at another observability that we are for our operationalizing Snowflake. What we do here is we operationalize Snowflake within RESTMed and across our subsidiaries. This is just one example of how we do it. There are multiple things to take into consideration. A simple task such as key rotation is as important as setting up role-based access, optimizing query performances, and implementing data retention policies. As a medical device company, we deal with a lot of PII and sensitive information. Many regulatory frameworks, such as GDPR and HIPAA, do advise on the importance of key management as a secure and robust strategy. Snowflake supports multiple active keys for an uninterrupted rotation. We're just following those recommended practices and ensuring smooth and secure key rotation within our company.
We're definitely not going to read this all to you. The deck will be available later if you guys want to take a peek. But this slide and the next slide covering some testimonials just kind of speak to the success that we've had operationalizing Snowflake at ResMed and what it's done for the company so far. So operability saves time and money, but all of this only matters if the answers are right. And so I want to talk a little bit about building trust at scale. So let's look at how data quality is realized and maintained continuously along the journey from source systems to Snowflake and beyond. As our integrations against systems of record land data in Snowflake, as that data undergoes merge, as policies are applied, and as that data is transformed in the context of data domain-specific business logic, the changes that occur are as significant as the need to ensure that those changes are furnishing accurate answers and insights. So the first objective for this order of operations is ensuring not only timeliness, but accuracy and completeness. In other words, parity with source through data reconciliation. So those three dimensions of data quality that I just mentioned, they don't lose relevance as transformation occurs, but the mechanisms that service them take a different form. Expectations are defined and tested against that cover all dimensions of data quality. And so to navigate this intricate lineage and meet the evolving demands of data quality, we built an extensible framework that's reliable, observable, and operable. It spans the entire data platform from the initial stages of data ingest and orchestration to transformation and consumption, as well as outbound integrations.
And how do we do this? We do this by governance. What is governance by design for us? For us, it's a fundamental principle that ensures proper policies are applied for protection and compliance of data at every aspect of our system and processes throughout, right from the very beginning. Our data catalog centralizes all our data assets, enabling efficient discovery and collaboration, while the master data management in Snowflake establishes consistency and reliability across our data platform. The features that Snowflake brings to bear are core to our ability to meet the world-class governance standards. By breaking down data silos and providing self-service tools and trainings, data democratization enables a data-driven culture, fostering innovation and agility at ResMed.
So taking a look at observability, this dashboard that you're seeing here is focused on the source side of one of our integrations. Two things I want to point out. That's a week's worth of data for one SOR, and it's about 700 million transactions that have been processed. You can see actually on that top left chart with the line, kind of the seasonality within the week, right? But also within the day. This is actually devices dialing in for one region. So as we kind of roll across time zones, those dial-ins kick off, and so you can see that peak each morning of each day of the week. And then when you're working at this scale, like hundreds of millions of transactions, whether you're on Confluent Kafka or AWS DMS or Click Replicate or any other tool in the space, sometimes, eventually, a transaction is going to get missed. And so we've actually patented a data reconciliation service. And it's an ongoing, exhaustive, self-healing data reconciliation. The implementation varies from SQL Server to RDS to Postgres to Dynamo to Mongo, but the idea is that any transaction that is not picked up as part of the normal pattern is recognized immediately, inserted into the proper place, and it doesn't slow us down when it comes to merge. So while Kafka is receiving data in near real time, and there are use cases which consume data directly and benefit from that low latency, the freshness of data in Snowflake is obviously totally configurable, and we optimize it based on the downstream requirements and the cost of loading data and effecting merge. So with quality and governance by design in Snowflake, why would we rebuild them elsewhere for machine learning?
So last year, we made a decision to use Feast in conjunction with Snowflake to develop a flexible machine learning platform. This platform provides capability and observability through automation of statistical matrix and bias and drift detection. Because our machine learning platform is predicated on Snowflake, the same governance principle that we saw earlier do not need to be re-implemented again. We just leverage them directly. In addition, we have incorporated Snowpark for feature processing, and Snowpark has similar functions and syntax to PySpark, which made the lift and shift model very easy for us. It was highly convenient for our data science team to leverage Snowpark's capability, and we also generally found it to be more performant. The data science team isn't the consumer of our data, but also the producer of the data. We have already paved a path for them to push the data back into Snowflake with the push model that we saw earlier in the presentation. In the next slide, we'll take a look at how we simplify machine learning feature discovery and serving while Snowflake stores and processes them at scale for streamlined customer-facing applications. So imagine a data scientist who is working on a model and training the data set. She's very focused on a specific table in a data set. To streamline the feature engineering, she employs Feast, an invaluable tool for defining and discovering the features. As she delves deeper, she has reached a stage where she's content with the initial exploration of the data. Now she takes her work to the next level by ingesting this into a feature store on Snowflake. By default, the feature store operates in an offline mode, which is what you see here. It is utilized for writing batch features and serving those features during the model training. Let's dive deep into how we initially set up our Snowflake and SageMaker offline-online feature store. On the top left here, you can see the secure views of our application data and an offline feature store in Snowflake. We use Airflow to orchestrate our data views, and for feature engineering computation layer, we use Feast. At this point, there are 3 computation options available. All of these options have the ability to write the features to Snowflake, SageMaker, or both. An application can consume the prediction by utilizing an API gateway. This can be done in 2 ways. One, we can add all the data to the API interface at the time of the request, or it can make the request to the online feature store or the offline feature store after the request is made. The application can also consume the data from the feature stores within Snowflake. And the predictions are also available in Snowflake. So this becomes an entire transition of the data set. It can also send back the data to the Snowflake for proper policy application. The SageMaker batch transform that is predicated using a step function writes back the data into our Snowflake feature store. With Snowflake's hybrid table that are still in private preview, the capabilities that they bring to bear allow us to retrieve these services in online use case mode. This will eliminate the need of the entire data transformation that we are seeing here, keeping governance still intact and not moving our data throughout the process. So we are looking forward for the public release of the hybrid tables so that we can simplify our machine learning platform, decrease the operation overhead of the existing pipeline, and reduce the time to productionalize these machine learning features. With that said, Snowflake is the foundation for analytics, BI, and machine learning, but it's quickly becoming a core component of our stack for both product and operations.
So taking a look ahead at what we're going to be working on over the remainder of this year and probably at least the first quarter of next, we're enabling data as a service for our customers, and we're doing that using data shares. So whether they're already on Snowflake or they need a reader account, this is obviously a highly improved customer experience compared to having to write an ETL pattern against an API. Also, we don't have to maintain the costly API implementations, and it's really paving the road for productized analytics. Another thing that we're working on is supplementing our systems of record, the hot storage layer, to enhance customer-facing products, and we're doing this in one case or to meet one use case, which is around cost reduction. And another, which is around adding value and exposing the output of analytics in our actual products. So, on the cost reduction aspect, we don't need to keep 12 years of sleep data in RDS. That data is not going to be changing after a short period of time, and so there's no reason that we should be storing it in a transactional system. We can keep it in Snowflake, serve it up to the application when it's needed, which is not that frequently. And that's allowing us to implement data retention across the board in our systems of record that back our patient and provider-facing products. We're also facilitating bidirectional integration with our operational systems, so everything from CRM to supply chain, logistics, manufacturing. And we're doing a lot of this, these internal and external use cases for customers. We're servicing them with a standardized set of APIs that are predicated on GraphQL, and they're built on top of data platform. And I think that's it. Thanks, everybody.
Thank you.